think it's very important to link teaching to industry and research, because that's how it becomes alive for the students. They can see how it's going to be a part of their future career if they go into industry or if they go into research.
If you can illustrate a point by telling an anecdote or an example from real industry experience, that will count for a great deal and students will appreciate it.
He used to demand that he test all my code, and he loved finding faults. It gave him a real kick when he found a mistake I'd made. I hated Ron. Okay? But I did discover, because of his testing, my code was better, and this was noticed by the powers that be. Good start to the career in that one.
Wherever possible, I try to share my industry experience with the students on that subject matter.
I used to work as a structural engineer for some time, so I could bring them my personal experience as an engineer and how I deal with some sort of situations, what-if situations, and how did I solve the problem.
Ricky often links the content that we're learning to what he used to do as a practicing engineer. He gives us actual examples that he's worked on, and he'll say we had to go through and do all of these things that we've learnt in class.
Of course, when I was an engineer, the technology was not as good as now, and so I would like to relate to the student that, for example, if you encounter this problem now, you would be using like the latest software to handle this situation.
Beyond that as well, like he'll discuss with us the credences of our standards for, say, the Australian standards that govern how we design our buildings here. He'll say, like, okay, so we don't have a standard governing this type of design, but it's an internationally recognised thing, and it's something that will pop up further on in our careers.
I think this is very, very much important because we're training engineers here in RMIT, and the engineers will eventually go out to the society and to build houses, to build bridges, to build water dams for the society. So linking the student with the industry, first of all, is very, very important.
If it isn't for that, it's just dry, boring theory, and the brain turns off. It's as simple as that. You have to find ways to stimulate them through the lecture, and this is certainly one of the best ways to do it.
One of the ways I link teaching to industry is I try and show videos and photos of the application of the concept in real life.
In maths, a lot of students I find it difficult to understand how concepts relate to everyday applications, and she works well at describing how they're used in chemical plants and industries.
So I'll open the lecture with, this is why engineers need to know this. I'll develop a link to future classes saying you're going to use this again, develop it in more detail.
She links what we're learning to real life examples and research. We learned about trusses and about the breaking points in bridges, so we were showing examples of that.
All the way through I try and show photos from the internet of it's a piece of equipment, and I'll trawl the internet for really good videos that try and illustrate the concept.
So I try to show the students animations on how the structures can be damaged, how the soil can be affected by ground deformation.
With every topic that we learn, he offers us real-world examples of how they would be used, including pictures, case studies and videos, making sure that we can understand where exactly this is applicable in the industry.
So you can see in this example a load-bearing wall scenario. So in this example, you can see the width of the foundation is very much smaller compared to its length.
The questions, for example, are of real problems, yeah, from construction site, for example. They, if they have any problems, we take the question into it and then, yeah, work out a solution for it.
Okay, that can be helpful for the students to build up their understanding, build up their enthusiasm, why they want to learn this theory.
I would show them case studies of, say, structural collapses.
Bridges and building collapses and considering death toll counts.
And show them the reason why those collapses happened. And so that the student will engage into, if they made a mistake in the calculation, in the design, what would possibly happen. So it was like a 2-story high space, and the entire steel roof came down. The reason to that is the roof, they put a lot of vegetation on it after the construction. And that will, again, relate to what they learn and enhance their learning experience.
The important thing that he tries to express is that, okay, we're not just putting in a bunch of numbers and ticking boxes. We're making structures that are going to avoid killing people. And I think that's the biggest connection he gives us to the real world.
The student will really get inspired, and they immediately will think about, oh, what went wrong? What could have been done to prevent those accidents?
It gives you the perspective of what our work will actually apply to.
So there's certainly an aspect of that there's a lot more out there than what we can simply cover in this course.
The reason I think students are so engaged by real-life example is because the student know they're going to become an engineer soon.
I think it's very important to link teaching to research and industrial applications, because it's about motivating the students, and motivation is the key to engagement.
Give the students on how this problem is done in the industry. For example, if there are certain standards that industry follow for this particular design of structure, for example, foundation design or retaining wall design, how the industry currently involves with this part of design.
Yeah, he often links that to the real world or to real jobs, because it's that like geotechnic engineers have to do that and that different fields of engineering.
Say that if you work as a geotech engineer, you will have to tell the project manager what is the ultimate capacity of the soil, but you will not tell to the project manager, this is my total capacity.
So I used to give in my teaching or my slides, they are the industry practice in terms of design of structures for this particular topic.
Yeah, it has to be as practical as possible to know what you're actually doing after finishing uni. Yeah.
So that's one of the ways that I try to give the students on application of what they learn in the class in the industry point of view, because that's what they would be doing when they pass out from RMIT.
No matter how good your performance, no matter how clear, how well explained, if the students don't understand or value what you're talking about and why it's of value to them in their future career, they're not going to be motivated to listen. So it's really key important part of awakening their motivation and interest in a subject that they might find quite hard, but because they're motivated, they'll put in the extra effort.
So the problems that we're learning, she tries to link the examples to real life situations in order for us to learn how to overcome obstacles that may happen in the future in the workplace.
Because that's how it becomes alive for the students. They can see how it's going to be a part of their future career if they go into industry or if they go into research.
Her examples help us understand with the problems which we might encounter later on in our career.
And so it's just a part of really motivating them to be interested in the topic. Even if the topic's hard, they can find motivation to try a bit harder, knowing how important it is.
But when you think about it, you've got 300 students and you're making a difference to them in helping them get a career.
PJ made it very clear when we entered our course that high school was over and it's time to join the real world, and we should be thinking like practicing engineers, not like students.
And please remember that we talked a lot about what employers look for in graduates, and teamwork is always there. It's almost unique. In fact, I haven't seen it for years that a graduate works by themselves. You work in a team.
So we're working with teamwork, so more like the workplace, and we've got to go through all the development steps ourselves. We don't actually get a lot of help from others. We've got to basically get frustrated with the tasks, research, and try out different things until we get it right.
This is why I include employability in this course. This is why I talk about professional skills so much, because that's what employers want will get you a job.
Because it's important for RMIT that the students, they graduate are work ready.
That's actually a really important thing, and that's what actually keeps me here at RMIT.